And those agencies take control of the process on behalf of another. In other words, if it's an agency dealing with health or corrections, etc., they don't have that expertise. So they step aside and they let, in this case, we have one called Partnerships BC or Infrastructure Ontario, and they take care of this part of it. So essentially the owner, in a sense, or the service provider is over here, and they have an agreement with this group. And then once it's procured, built, this group then steps aside, and it's the actual availability check is cut by whether it's the health or corrections, whoever it is. They then make the payments, not in. So Infrastructure Ontario and only deals with the delivery mechanism. And then the day it's finished, they step aside, and then the real owner, in a sense, or the service delivery, writes the check.
So you get one more click on that slide.
Oh, yeah.
And there you go. And maybe another click too. And then there you go. Okay. So this slide, I love this slide because it has it all together.
Yeah.
And so that's where, and this shows where how your money's going into the deal.
That's right. Okay. So now we're going to fast forward to risk. So the basic theory in these is that you transfer the risk to the group that's best able to manage that risk. And if government transfers some risks, it's going to be paying a very steep price. So each partner is looking at what risk they can take on, and they're trying to figure out what premium they want to pay for that risk. So if the developer takes on the risk of cost overrun, they have to figure out what that risk is and how much of a premium they're going to charge. And the other part of the risk is the whole life cycle risk. They're taking the risk of that building operating and being functional for 30 years, which would, you know, in real estate you could sign service agreements, but whether the roof membrane stands up or not, that would be the owner's responsibility of the building. The other thing is that from the private sector, they can only accept risk if it can be described, managed, and priced. So just to give you some idea of what I'm talking about, here's some of the risks, and here's who would take it, and here's the reason. So design and technical risk is clearly one that the private sector can take on, because that's a core skill that they have in designing and understanding the technical. Land assembly, the public sector. Because if the public sector is going to grant a concession, they're going to have the land. And land assembly is again, it's one that the public has to take on, because sometimes it's got to be done by eminent domain, et cetera, et cetera. Environmental approval risk, usually the public sector, because again, that requires the public to deal with their own processes. Construction is the private sector. Operating risk is the private sector. Demand risk is an interesting one, and this is where a lot of projects fail. It's mostly the public sector, but the problem is that it's simply that the private sector doesn't control many of the factors of demand. In other words, let's say you're building a prison. They don't have any control over how many people go to prison. As you know, in California, it's an interesting story. They have what they call the 3-strike law. And I don't know if you're aware of that, but in California, if you're charged 3 times, sequence, you get a life sentence. Now, it drove up the demand for prisons. And if you look behind the law, you discover, in fact, that it was strongly promoted by the unions, the guards. Because, and what's happened as a result, California's cut it aside, but about 25 years ago, about 5% of California's budget was on prisons, 15% universities. Today, it's 15% on prisons and 5% at universities. So you get this sort of perversity that goes on sometimes. It shows you how demand is driven in the public sector, often by policies that sometimes are legitimate, sometimes they're not. So the private sector really isn't going to get involved in that. The public may say the demand for the highway is this, and then something happens, they don't close the alternate route due to political pressure, and demand disappears. So demand risk should be mainly on the public. Financial risk is mostly private. Environmental risk is mainly private in the sense that this is, again, a core skill of the private sector in how they actually deal with environmental risk of building a road, etc. And then regulatory risk is the public sector. So this is only a tiny fragment. And people literally sit in a room and make a big list. Now, to go back, most of the infrastructure projects are inherently risky due to the long planning horizons and complex interfaces. I mean, these big projects take a lot of germination time. And also during that, there's a lot of unplanned events that occur. Going back to the data, in 1999, the UK National Audit Office said that 73% of public construction projects exceeded the price, the agreed price, and 70% of the projects were late. So that's not a very good record. And you saw before, the magnitude of these costs and time overruns are significant. There's a famous study done by an academic out of, I think, Sweden, Flyberg, and he did quite a thorough analysis of this. He found that 90% of projects have cost overruns. Overrun is found in the 20 nations and 5 continents studied. It was a very comprehensive study. The overrun is constant for the 70-year period of the study. Results have not improved over time. So over that 70 years, there was no evidence that government was learning from its mistakes. So here we are. 58 rail projects showed an average almost 45% cost overrun. 33 bridges, cost overrun of about 34%, and 167 road projects showed about a 20% cost overrun. So you can see why governments are concerned. Just if you look a little closer to home, the Boston dig was $11 billion over budget. That's a famous, I lived in Boston then. That's a famous story. It was 275% over budget. The Pentagon spy satellite was $4 billion over budget. The Denver airport was 200% over budget on a $5 billion project. The Channel Tunnel was 80% over budget for construction and 140% over for financing. And the Sydney Opera House was 1,400% over budget. So, I mean, obviously I'm picking things that are rather extreme, but you know, it gives you some idea that governments just have not been able to deliver these projects. And so this research is helpful.
We were at a project last week, our class went to it, and it was for a government agency. And it was $160,000, $160 million. Then they changed, they added a data center to it. Inside of it, which was another $160 million.
Yeah.
So they literally doubled the expenditures, based on the initial budget, you know, now, have you looked at this library study, he adjusts for all those change orders? So to speak?
I think they probably did. They probably took a project like that and took it out of the survey, I would suspect, because it's not untypical for governments to start with one thing, knowing that they're going to end up in another.
Right, change orders is just how they do business.
Yeah, yeah. So I would assume that he probably precluded certain, just to keep, you know, sort of veracity of the study intact.
You know, I think our capital visitor center was a $50 million project, and ended up at $450 million.
Yeah.
That was while we're at it, you know,
Let's
since we're
do-
here, yeah, we're never gonna be building another one of these, let's add this on.
Yeah.
I went to a lot
Yeah.
of those meetings.
And there's
so-
there's no penalty for there's no penalty against doing that.
Right.
The only penalty is it could be imposed if we don't have money. So what we do find is that the benefits are often inaccurate, and that is that the patronage and the traffic forecast for use are really far off. 90% of rail projects, these all high-speed rails, overestimated traffic. 25 rail projects had average inaccuracy of about 51.4%, with a standard deviation of 28.1. Pretty bad. 50% of road projects forecasts were wrong by at least 20%. 183 road projects had an average inaccuracy of 9.5. And so what they found was that the only thing that was constant was the ability to make mistakes. So that inaccuracy was a constant over the 30 years, and these forecasts have never improved over that period of time. So there's something systemic in the way that government delivers on the traditional model. So if you look also at these projects, we notice a very poor integration of CapEx and OpEx. In fact, many of these public projects don't do any kind of work on the operating costs. So there's very little data, unfortunately, on this. And most of the data is a history of what we call patch and repair. So as I mentioned yesterday, if you're doing any kind of asset management, we know that it runs between about 2 and 4% of your capital costs. The City of Montreal has, in Canada, when they approve a new public project, they must budget 2% in their capital budget ongoing for that. Most governments do not include, when they build something, will they include in their budget going forward the maintenance of that facility. And so we also have a model called design, build, and forget. And that's very typical. The record of performance is one that's costing the taxpayers a lot of money. To date, in our experience, we've got about 180 projects completed or underway with a value of about $60 billion. We generally see about an 8 to 15% value for money on social, and about 20 to 30% on civil and economic. So we're now getting to the point where we're beginning to sort of see the aggregate data. The biggest problem we have is what's going to happen in year 10, year 15, year 20. Everyone's sort of saying, but most of these are new. So it'll be interesting to see whether they live up to agreements over time. So what you normally do is they sit in a room, they put up a big matrix, and this is the exercise they go through. They decide, here's traditional. So as we know, in the traditional, design, build, finance, maintain, everything's in the public sector. Now, if you go to a PPP or alternate finance or PFI, whatever you want to call it, you've got three choices. You can go public, you can go private, or you can go shared. And so, as you go down the list, you now see that as we move to this model, the only one that the public will retain is the risk of changing their specification. in the middle. Because that can substantially, now on the private is willing to take all of these, and when it comes to certain things, they decide to share it. A good one would be functionality, where there is a change in the function of the building, and it's clear that the contractor or the developer and the public and their partner can sit down and figure out how much of it is going to cost you and how much can we just simply modify the existing one. Geotechnical and environmental down here, and some land acquisition, again, it's shared. They may say, for example, on this site, we'll budget $140 a cubic yard for removal of contaminated soil, and we'll cap that at this amount, and everything over that, the public has to pay. So in our model, we'll account for 12,000 cubic yards of contaminated soil at $140, or another good one would be asbestos. If we're having to demolish an existing building, but we don't know until we start digging. Or another one might be you dig your foundations and you hit water. Going down, a good one is protests. It's shared because the contractor sometimes can figure a way that they can still do some work, and and the public. So it's a shared, and also inflation is shared. So I'm not saying that this is a template. I'm just giving an example of how you go from here over to here. So if you're submitting your bid, you've got to prepare this template and submit it. And then once you've done these X's, now you've got to figure out the price, what the risk is, and price it.
When you said under finance, currency, and that's going to be a risk of the private sector,
Yep, they take full risk.
well, how do they do that? By trades and hedges? Or, I mean, the currency, isn't that a function of the government policy?
Pretty hard to hedge over 30 years. I'll tell you how, in fairness, it is shared a bit. What you do on your bid is you give a base, and then at financial close, there's a spread. Okay, so you may go in with a base of 2.5, which would be the cap. Okay, our base would be what in American called T-bill rate. Okay, so your base would be T-bill, which would be your cut your lowest rate on a bond. Then what you would do is you would say a financial close will do the spread.